step by step. This is one of the objectives, how to solve a problem for a car which is taking a turn on the road. You can see that, you must have read that there is a car which is taking a turn on the road. Now it is clearly shown in the diagram that the first step has to be labeling the forces. Yesterday also we did this, labeling the forces. Now this is an example, so you can see that they have already shown you a diagram with labeled forces. In exam, you have to label the forces by yourself. So when you read the question, you will see that the road is having friction. Let's read. It is written, if the radius of the curve is 35 meter and coefficient of static friction. So immediately you know that there is friction on the road, and you know that you have to label friction in the diagram. Now my question is, how do you know that the friction is towards, in this case, towards left? How do you know that? If this is the diagram given, the friction is towards left. You will raise your hand. We have the, yes. Friction is force, okay, but force can have any direction. How do we know to? You will raise your hand. Anybody else? Okay, let me ask you something else. What is the direction of friction? What have you learned about direction of friction? You will, opposite to direction of motion. Okay. Now the road, you can see the road is in a curve, and the car is moving ahead. Correct. But you know that when a car takes a turn, there is a possibility of slipping from the road. You know this, yes? So the car can slip out of the road. That means the possible motion of the car is this way. The possible motion of the car is out of the curve. Do you understand that? Yes. It is not doing that because of friction. Friction is trying to hold it into the curve. That's why we say that when you are having rainy season, or you are having friction is less on the road, the car can slip because the friction will reduce. Is that clear to you? So you know now how to draw the direction of friction on the diagram. Other than friction, you have mg and n. What is that small n which you see there? Normal. It's a normal force. We usually write it as Fn, or we write it as capital N, but in this textbook, it is written as small n. That means throughout the textbook, where you see small n, that is normal force. Okay? So we have labeled the diagram. Now we'll go to the next step. First, we need to know what we are trying to find out. We are trying to find out what is the maximum speed. You want to find out what is V. So we have to look for a formula which gives you V. We have learned one formula which gives you V. What is that formula? Raise your hand. Raise your hand. Which formula gives you V in this chapter? Yes, Abdullah? A is equal to V square over R. That means the centripetal acceleration is equal to V square over radius. Now we have the radius, it's given in the question, but we don't have A. Do you see that? We don't have acceleration. And how to get acceleration? Raise your hand. What are the two ways of getting acceleration? What are the two ways of getting acceleration? Yes. Sorry? Newton's second law, excellent. That means you can get acceleration from force, or you can get acceleration from change in velocity divided by change in time. You have two formulas for acceleration, you know that. Yes. But you know that we are not going to use change in velocity by change in time, because we have the information about force. So we are going to use something related to force. Now let's see what's the next step. Now you can see that the friction force which is acting towards the left is actually pointing towards the center of the curve. Do you see that? So that means friction force will be the centripetal force. Okay, so once again, friction is towards the center of the circle. That means friction is acting like centripetal force. Okay, so you can see that friction, you have learned this formula before, which is coefficient of friction multiplied by normal force, mu n. You remember this? Friction is equal to mu n, which is going to act as the centripetal force, which is equal to mv square over r. Centripetal force, we learned the formula yesterday. The formula is mv square over r. So we equate friction to mv square over r. Okay? If you have anything to ask, you will ask now about this equation. Abdullah? Okay. Now, from this equation, we go back to the question. It is asking for which quantity? It's asking for velocity. We rearrange the equation. We see that there is a square here. We take square root of the equation. After this step, we look at the y direction. Look at the y direction. In the y direction, how many forces are acting? Two forces. Is the car moving up and down? That means that both the forces should be equal and opposite to each other. Now, who will tell me, once we get this equation, why should we go for the y direction? You need to raise your hand to answer and you need to focus. Abdullah. After this equation, why should we go for the vertical axis? Why can't we just substitute the values and get the answer? Do we have